Good evening. Dear student, in the previous video we have discussed Newton's first law of motion. Today we shall discuss Newton's second law of motion. Before we discuss Newton's second law of motion, let us clear the concept of the momentum. Momentum of a body is defined as the force possessed by a body due to combined effect of its mass and velocity. Obviously, a truck of huge mass at rest cannot exert any force because its velocity is zero, and the combined effect of the mass and velocity is therefore zero. So the momentum is the force which is possessed by a body due to the combined effect of its mass and velocity, and it is equal to the product of mass and velocity. It is a vector quantity and its SI unit is kilogram into meter per second. SI unit of the mass is kilogram into SI unit of the velocity is meter per second. So SI unit of the momentum is kilogram into meter per second. Now consider that a body of mass m is moving with an initial velocity u. So its momentum is initial momentum mu. Now consider that a constant force Sf is applied on it. Now since the force is being applied, so its velocity is likely to change. Let its velocity changes from u to v in t time. So the momentum of the body after the application of the force is mv. What would be the change in the momentum of the body? The change in the momentum of the body obviously will be final momentum minus initial momentum, that is mv minus mu. And since this change is taking place in t time, therefore we can say that the momentum of the body is changing at a rate of mv minus mu over t. So what is this? Rate of change of momentum. So we have seen that the application of force, that is when the force is applied on a body, the momentum of the body is likely to change. Newton's second law of motion explains the relation between the change in the momentum or the rate of change of momentum and the force applied. And it is this relation which is known as Newton's second law of motion. So Newton's second law of motion states that the rate of change of momentum of a body is directly proportional to the applied force, and this change takes place in the direction in which force is applied. What the statement? The rate of change of momentum, यानी बॉडी का जो मोमेंटम चेंज होता है फोर्स के कारण से डायरेक्टली प्रोपोर्शनल होता है. दैट इज इफ the magnitude of the force is doubled, the rate of change of momentum is also doubled. This relation is called directly proportional. So if two physical quantities are related such that if one physical quantity is doubled, the second physical quantity is also double, they are said to be directly proportional. The rate of change of momentum of a body is directly proportional to the applied force, and this change, that is the change in the momentum, always take place in the direction in which the force is applied. और जो मोमेंटम चेंज होता है इसकी डायरेक्शन उधर ही होती है जिस डायरेक्शन में फोर्स लगाया जाता है. अगर आपने जिस डायरेक्शन में बॉडी मूव कर रही थी उस डायरेक्शन में फोर्स लगाएंगे तो उसका मोमेंटम भी उसी डायरेक्शन में चेंज होगा. इफ द फोर्स इज अप्लाइड इन द अपोजिट डायरेक्शन, द मोमेंटम इज लाइकली टू चेंज इन द अपोजिट डायरेक्शन. नाउ लेट अस derive this relation mathematically. So consider a body of mass m is acted upon by a constant force F, so that its velocity changes from initial velocity u to the final velocity v in t time. Now the change in momentum is equal to final momentum minus initial momentum. Final momentum is, final velocity is v, mass is m, mv. Initial momentum is mu. So change in momentum is equal to mv minus mu. Now, according to situation, this change is taking place in t time. Therefore, since this change is taking place in t time, therefore rate of change of momentum what is rate of change of momentum? That is the change in momentum in unit time. In t time, change in momentum is mv minus mv. इस सिचुएशन के अनुसार तो मोमेंटम चेंज बाय टी में, टी टाइम में वो कितना है? mv minus mu. Therefore, in unit time, the change in the momentum will be by unity system mv minus mu over t. So this is rate of change of momentum. Change in the momentum in unit time is equal to rate of change of momentum. So rate of change of momentum of the body is mv minus mu over t. Now let us recall the statement of Newton's second law of motion, which states, क्या कहता है? The rate of change of momentum is directly proportional to the applied force. Therefore, according to Newton's second law of motion, force applied is directly proportional to mv minus mu over t. इसको कैसे पढ़ेंगे आप? The rate of change of momentum, यानी the force applied is directly proportional to rate of change of momentum. Or F proportional to m into v minus u over t. Or F proportional to m into a. Why? Because v minus u over t is equal to a by first equation of motion. or when two physical quantities are proportional to each other, their ratio is always constant. Therefore, F over ma is equal to constant. In physics, this constant is represented by K. Therefore, F over ma is equal to K, or F is equal to K into ma. Therefore, F is equal to K into M into A. What is this K? Where K is a constant of proportionality. Unit of force is defined such that the value of the K is equal to 1. In physics, SI unit of the force, that is Newton, is defined such that the value of K is 1. Let's see how. Newton. If M is equal to 1 kilogram, A is equal to 1 meter per second square acceleration, then substituting the values in this equation, we have, अब सुनिए, listen to me. F is equal to ma, or m is equal to 1 kilogram, acceleration is equal to 1 meter per second square, so F is equal to 1 Newton. So 1 Newton is the force which, when act on a body of mass 1 kilogram, produces in it an acceleration of 1 meter per second square. 1 न्यूटन फोर्स को कैसे डिफाइन किया गया है? 1 न्यूटन फोर्स उतना फोर्स होता है कि यदि वो किसी ऐसी बॉडी पे लगे जिसका मास 1 किलोग्राम हो तो उसमें कितना एक्सेलरेशन प्रोड्यूस कर दे? 1 मीटर पर सेकंड स्क्वायर फोर्स प्रोड्यूस कर दे. नाउ लेट अस अप्लाई and find out the value of K. So F 1 Newton, mass 1 kilogram, acceleration 1 meter per second square is equal to K. 1 into 1, 1. 1 over 1, 1. That is K is equal to 1. So if the value of the K is 1, this expression is reduced to F is equal to ma. This is the mathematical expression for Newton's second law of motion, which also defines force. That's all today's.